check a few things. I think we're live, and it is Tuesday, May 1st. So, last time we accomplished a lot of stuff. We, as usual, we created these, what do you call them, buzzsaws, and as well as these rotating 3D blocks. So, let me just demo that for a second real quick. As well as, like always, I'm going to remind everybody that if you want to participate in the streams, whether it's just by watching, you can watch and you'll accumulate points every 5 minutes. Technically, they're called gold bars because I think that name's kind of cool. So, you can earn gold bars just by watching the stream, or you can play along and help us code some stuff. And if you're able to solve some problems that we come across, then you'll get extra gold bars as a reward, and you can redeem those points for some of our games. And you can see our collection of games down below beneath the video, as well as a list of everybody who has their points. And I think instead of announcing them at the beginning, I'm going to announce at the end who is in the lead. So at the very end, because you know, as we do it, people will earn more points and stuff, so maybe it'll change. And so at the very end of the stream, I'll let everybody know who's in first, second, and third place with the points. Not that it really matters, because, you know, you don't have to feel like it's a competition, but it's at the same time it's pretty cool if you feel like being first, second, or third place. So anyway, because everybody can, like, there's no supply, or I should say there's no limit to the supply of the games that we have available. So whenever you accumulate 1,000 points, you can get yourself a free $1 game from our collection. And this thing stopped moving, so that's not good. But oh right, that's one thing we have to do. So as you can see, we've got the buzzsaw that I've sort of been flying around, and it's sort of going kind of slowly, and we've got this thing that rotates, and it's a little bit hard to stay on top of it sometimes, so we'll need to make that visually more distinctive. But like that, there we go. So he's on it, and then it rotates a little bit, and then he starts to fall. It's very slow, but yeah, there we go. So anyway, that's what we did last time, and might not seem like much, but it took the whole 2 hours, as everybody who was there can attest. So let me check and make sure that we're still live. Okay. I don't know what happened. For some reason, my browser glitched out, I think. So tonight, we have some options, like usual. Okay, yeah. I always just like to keep the stream up in another window so I can see what's happening. For some reason, it didn't quite work. Alright, so anyway. We have some options. I think what I want to do first is add... well, I guess first thing we need to do is fix this. So what's wrong with this? This should rotate the Z. So you think that will work? Should the speed be greater, maybe? Let's try it. Let's find out why that isn't spinning. The speed probably needs to be a lot more, because we changed the way that works. So, yeah, there we go. Okay. So that's all that is, and we got to change these two. So maybe we'll bring that down to -30 instead of -50, because that was kind of fast. So I'll just get to work fixing some of this stuff real quick. So these things, I'm not sure if this is going to work, because well, this doesn't need to work. That doesn't need to be rotated. But this one, this triangle and the other triangles, they are supposed to rotate. And so let's see what happens. So how did I do this? Well, I guess we're just going to jump back into this. So end of the code, I mean. So we did it like this. If wait time is greater than 0. So the idea behind this chunk of code here is to wait X seconds before spinning again. So after 360 rotation, basically. So we want to go 360 degrees back to the start point that we were at, and then wait a few seconds, and then spin again. So, hey, howdy, Sound T777. You are actually... I'll make one exception since I think you are currently in like second place for the points system. But yeah, we'll see who's in the top 3 by the end of it. So anyway, I'm pretty sure you're in the top 3. The thing is taking a few seconds to load, but you guys can check yourself. So yeah, let me see here. So last time we made some adjustments to this part of the code, and now we're gonna look at this part of the code because the way we change things is pretty different now. Well, not that different, but it affects this part up here. So let's see what we need to do. Where does this come from? Okay, well. So this is the amount of seconds we want to wait. So if that's greater than 0, then we want to... what am I doing here? Either begin turning or stop turning, I guess. Let's put these comments up here, outside of the if statements. Okay. Let's see. So total degrees, right? So that's, we were adding total degrees up so that we could know when we make a full rotation. So what we could do instead is just check to see the Euler angles. Well, if it's equal to 0, then we know that we're back at our starting point, basically. And if it's not, then we know that we're still turning. And probably what we could do is just add a little bit to it, just so it's no longer actually 0. So we'll just do this on the z-axis because for right now that's all we're messing with. If it's equal to 0, and just for completion's sake, I'll say we'll cast it to an integer. That way, if it's some sort of floating point number that's not precisely equal to 0, then it will be equal to 0. So we don't need this anymore. Well, what we want to do is we want to take we still want to rotate it like just a bit, I think. We want to rotate it a little bit so it's past 0, just a tiny bit maybe. Well, no, that's not right either, because it'll just cast it back to being 0. If it's 1, because I was thinking, well, we can make it 1 so that it's no longer 0, and then it just rotates back again. But we might need a... That's probably what this is for. So, okay, so next rotation time is the next time that it takes to rotate, which is time.time plus wait time. So, we'll say... Yeah, I'm confusing myself with that here. Let's just do this. So by default, this is going to be -1. And if if it is -1, which at the beginning it will be -1. So let's get rid of this for right now. That's confusing me. So basically what we're saying is if time.time is greater than next rotation time. Oh, I see what's going on. So this is basically saying, yeah, I gotcha. So when it's -1, then we don't want to rotate at all. This is basically telling us that we don't want to worry about the time, because so we'll start at 0, let's say, and then we do one full 360 rotation. Then we and at this point next rotation time is going to equal -1. Then we do full rotation. Then next rotation time equals time.time, basically some time after the current time. Then we do one more. Well, before we do that, we need to wait. So we just wait for time, and then after we wait for time, then and the cycle starts over. So that's basically what we're doing. If it was hard to follow what I was saying, so I'll just leave that there for a second, just so people can see that. So that way, this will only check to stop turning if we do that. And so the other thing that we need to do is we need to set our Euler angles, I guess. And a simple way to do this is just to rotate ourselves a little bit. I don't know what this is going to yield a result in, but let's do a debug.log before and after so that I can see what it does. I want it to like change itself by 1 degree, basically. Well, let's just do that. So I feel like with this we're going to get pretty close to the right answer, but we're not going to get exactly there. So let's just try it out and see what happens. Let's see. And let's decrease the wait time just so that we don't have to wait that long to test this out. And while this is loading, I'll just mention once again that I've updated the Goldbar Games website. If you go to goldbargames.com/games, you can see a list of all of our games that we've already made and that we're currently making. And maybe today, well, probably tomorrow, I'll have to add the page for Snowball Safe Summer. I've got the link working, it just doesn't go to the right page. Hey, look at that. Now the question is, does it rotate again? And yes, it does. So it seems like that works. What's the debug log showing? Let's see. What is this? Okay, we need to get rid of that. Okay, I'm not quite sure what that's doing, but it seems to be working, right? 1001, 1002, and it goes again. Yeah, I guess that works. Can we change the wait time like this while it's playing? 1001, 1002, 1003, 1004, 1005, 1006. If it goes again, we're good. If it doesn't, okay. Alright, so I guess I did better than I thought I would do. For a minute, I got scared that I forgot to switch the screen again. Man, I hate it when that happens, but luckily we're okay. So that's done. So that's a good thing. I'm just going to get rid of the debug statement. That didn't need to be there. It's just taking up all sorts of time. Or not time, it's taking up space. Anyway. So next thing I want to do is start adding some new stuff now that we cleaned up some of our mess from last time. So one thing that I wanted to try to do was improve the switches that we've had in several of our levels by now. We've had switches that can activate things, and I want to improve them a little bit. So let me drag Snowball over here to the right a little bit, so we have some room to play around with some stuff. And we'll put him over on this side. Let's see. We'll go back to 2D mode, and I want to make sure that the level bounds are large enough. So, okay, they are. So at this point, I want to add a switch in. Where is it at? Okay, so I want to add a switch. Oh, apparently. Hold on a minute. I need to re-prefab these switches. Let's see. Let's go back to, is it 11? Wait, cancel. No. It's 10. I want to find the one where the switches were actually, they look good. Yeah, right, like this one. Okay. So I'll just call this a switch, and we will overwrite the old switch. Hopefully everything is still intact after that, but we'll do that. And now let's head back into yeah, okay, I think we're good. Let's head back into this one. And I want to drag that switch into this level now. And actually, let's move Snowball a little bit back. And I want to duplicate this triangle right here. Is that the one that we changed? Here, let me copy and paste all this stuff. Oh, and we're going to want to add that checkbox to that one. All right. Oh wait, that was the wrong triangle. Let's go for this one. Okay. Okay. Did I? Yeah, I didn't copy that yet. Okay. Just copy this one, duplicate it, just bring it over here, a little too far, and maybe you'll start to see what I'm trying to do. So I want to make the switch affect this platform. And you might wonder what way I want to make it affect the platform. Well, we'll see in a second. Okay, so the switch is right here. We'll just attach it to this little box, I guess. It doesn't matter. Switch is gonna be right here. And so we're gonna need to modify this a little bit. I was thinking about this a little bit earlier today, and instead of just typing the names of these functions, we should probably have some sort of enumerator that, or an enum that we can just pick from, instead of just typing in a string and sort of hoping that it works out. We should just have like a drop-down menu that we can choose from. So that's what we're going to do, I think, first, before I get into the details of this. So we'll do, I guess I need to open it up. And this is probably going to wreck all of the switches that I've made for all the other levels, so oh well. But we won't have to do this again, I think. So, let's see, string function to call. This is kind of what we had. This is kind of what we had figured out a few weeks ago, or days ago, I don't know. That we classify things as either an object or a complex object. That the complex object would take a parameter and in the function. Well, yeah. So Well, really what we can do is just get rid of this now that I think about it, and we can actually just call two different functions, I guess. When do these get called exactly? Yeah, I know what we can do. We can do a public bool takes parameter. Oh, actually, what we can do is I wonder. I wonder if we could do something like this, where it's like string parameters, and then we can say if parameters dot length is greater than 0, then we do that parameters, else we just send a message without a parameter. I think that works. Let me see if that compiles. It seems like it compiles. Yep, okay. So I guess that's gonna work, and that means we can get rid of this thing. We don't need just that object anymore, and we can rename this to a switch object. So I'm gonna have to redo all those switches that I had in those other levels, but that's alright. So it's pretty good. I wonder if this should be affected object instead of effect object. Yeah. So this completely destroyed all the stuff that we did with all the other switches and all the other levels, but we'll have to deal with that. So the last thing that we need to do, which like I said at the beginning, is create some sort of enumerator for this. So we'll do public enum class, or we can just do public enum. I'm not sure what the difference is, to be honest. How did I do it for these other things? There's like, let's see, game state. What is this? Public enum state. Okay, I just like to copy and paste this stuff. It's a lot easier to deal with. So we'll do public enum. Let's see. So we'll do something like, we'll call it a switch function maybe, and we'll have like what are some common functions that we've had? Well, we've had from the follow path function, we've had start moving and toggle moving and reset position. So those will be some functions that we'll have to call. So start moving, toggle moving, reset position. So there we go. And we're also going to have to deal with the water, because we did that. We did that one level where the water rises up. So we'll call that one match height, which is what we said it was in the other script from the other day. So we've got 4 functions now, and we're going to have, instead of calling it a string function to call, we're going to say it's a switch function. And then what we're going to do is down here we're going to say I guess we're going to have to do like a switch case statement, I guess. It's not the best thing, but anyway, string function equals that. Then we'll just do switch function to call case match height function equals match height. And let me just copy and paste this. There might be a better way to do this. I don't know. Wait, we can just do that, and we can do that. We can do that. Is that everything we have? Yeah. And just by default, we can just break. And we can say if function equals nothing, then we can say debug.log error. Error switch does not have a defined function. Okay, so or I can say switch switch affected object. So this is just telling us that we've said that an object is going to be affected by the switch, but we don't have a function that corresponds to it. I'm not sure if that's ever actually going to happen. I'm not sure this will ever happen, actually. Anyway, doesn't matter. That's okay. It's okay if you had to do something else, because these are all archived and you can watch them whenever you need to. So let's see what's going on here. 95 string object has invalid arguments. Oh right, duh. I forgot to replace it this to this. There we go. Now let's see if it works. It should. Those were the only two errors. Yeah. Okay. So now that we have that working, let me go back into the code, and we're going to add a new one. We're going to add change speed. So you might see what I'm going for here. We'll add down here as well, change speed. And we can just do that and that. That's actually not that difficult to change it around. And so there we go. So now we're going to be calling change speed, and guess what we'll call it on? We will call it on the rotator. So we'll have a public void change speed function. Oh, and it's going to take an integer, of course. So, or maybe it'll be a float. What is it? Yeah, it's a float. So we need a float. Let's see. Well, no, actually, it's a string, because we're always passing in a string. Let's see. Yeah, string speed, and then what we're going to do, or we'll call it new speed, just so we don't get confused. New speed, and we will say speed equals new speed. Well, we need to convert it from a string to a float, so we do. We need to use system for this. So using system, so equals convert dot to float, no, to decimal. No, I think it's to decimal. No, wait, float dot. Okay, this is it. Float dot parse. There we go. Float dot try parse. We'll say. So new speed is the string, and the out float. So we'll say out speed, and we'll say if. We'll say if we can't parse this, then we'll say debug dot log error. Error cannot parse new speed string. All right, so that'll tell us if there's a mistake. So now the only thing I'm not totally sure about is if like we're passing in an array of parameters, so I don't know if, since that function only wants one parameter, like I don't know a whole lot about the send message function. It's sort of built into the mono behaviors in Unity, and I've been using it for a little bit to to use the switches. So let me take a look at this for a second on the documentation. An optional parameter value to pass to the called method. I mean, I don't know. Let's see what happens. Let's see what happens if it expects a string, but it gets an array of strings. What happens? So, because I'm not sure what will happen, and the best thing to do when you're not sure what will happen is to, well, okay, this is terrible advice in general, but don't just randomly try things and hope that they work. But it's okay to do it if you're in a safe environment such as this one, where our consequences aren't really that significant. I would not advise just doing random stuff and hoping that things work out, unless it's in something like this. So we've got our switch, and we'll say affected objects is 1, and it's going to be this guy right here, and we're going to make him change his speed, and we're going to have one parameter which is the desired speed. So we'll make it go at like 100, like super fast, so that we know that this works. It'll be crazy fast. Actually, let's do 1000. That's almost too much. Let's do 500. Okay. So we got all of that in place. I think I just want to check and see that this looks right. Yeah, so it'll go 10 times as fast when it rotates. So let's hit play and see what happens. Okay, so it rotates as normal, and I should have moved that guy a little bit closer to this thing. Okay. There we go. So, invalid parameter. All right. So, unfortunately, we need to modify something real quick. So, I guess what we're gonna have to do is just always take in multiple strings and just deal with it. Where'd it go? There we go. So we'll take in an array of strings, new speed. There might be a better way to do this, but we'll just say new speed 0 is the one that we're going to use. So, yeah. So we'll just take in the whole array and then only use the first element in the array as a parameter. So it's quite possible that the array will not be very large, and it really shouldn't be. Like, I'm the one designing the levels here, so I shouldn't be doing anything that will intentionally break anything. But see, there you go. So we changed the speed. So clearly that works. And now that's going totally bonkers. I don't know why. Why is that working? I bet it's because maybe it's rotating so fast that our condition that we said earlier just never happens. See, it took that long to get there because it's rotating. It's just rotating so fast that it never gets to that point. So probably what we should do is actually rotate it. We should actually keep track of the total degrees like we were doing the first time. So as you can see, we've identified a flaw in one of our algorithms, so let's go back and change it. I'm glad that the switch works, though. It's actually better than ever, really. So we'll go back here, we'll have total degrees, and do we have a start function? No, we don't. I guess that's good enough. So we'll do... Yeah, that's okay. That doesn't quite work. So we'll set that equal to 0 here. We'll say total degrees is greater than or equal to 360. And then we'll set it to 0. Actually, let's do 359. Well, no. So what we want to do here is every time we rotate a little bit, we need to add to our total degrees the amount by which we moved. So basically, we just want to we want to get the difference in degrees. So let's say, let's call it the degree difference maybe. So this is going to be our old time, or our old z value, and then we're going to rotate it. Yeah, let's get rid of that. We don't need that there. Yeah, we really don't need this at all. But let's see. Yeah, I don't think we need that at all. So we'll take the old degrees, then we'll rotate it. And what will we do? Just forget about this, all these axes for right now. What's the key to developing a good game, XD? Well, there's probably a lot of keys to developing a good game. I don't know if there's just one. I would say, if I have to pick just one, I would say a good game probably, well, it depends what you mean. If you mean like a fun game, if you need to know what's fun, then I would say get lots of people to tell you whether or not it's fun for them. Like, you know, what's fun about this is that I can get your guys' opinions and see if you guys are responding well to what I'm coding or responding well to new gameplay mechanics. But, you know, you also need to have a lot of creativity on your own to make a fun game. Of course, there's a lot of other stuff like other keys that might be good, or like, you know, you want a well-programmed game that doesn't have bugs in it, and it doesn't, you know, it doesn't have problems. It runs well. It runs on all sorts of platforms, and, you know, so you need to have problem-solving capabilities. I'd probably say, just in general, problem-solving capabilities is what you need to make a good game. Like as far as constructing a good, like a working product is concerned. But if you want to make a game that's fun and appeals to a lot of people, I'd say just probably the thing you have to do is get it out there and see what people respond well to and see what they don't respond well to, and just modify things like that. And always come up with new ideas. Oh, nice. Thank you for the follow. So hopefully, I guess I must have answered your question pretty well because you're following now. No clue what you're using. I'm still a school kid who has no clue how to code. That's okay. We were all there at one point. I used to be a nub school kid who didn't have any idea how to code either. C-style programming. It's pretty close. It's C#. So yeah, I guess that would be considered C-style. It's C#. So this is Unity, and if you want to see a look at the editor, what the game sort of looks like, it's this. This is just one level, of course, but you can see you can see the whole editor. There's all sorts of objects in the scene and all that. But let me finish this up real quick because we're almost done with this section. So we want to get the difference in the degrees between the rotations, and yeah, another good skill to have is a lot of mathematical knowledge. So as you'll see, you know, you want to study your math and all that and stay on top of engineering stuff. You don't have to be a total genius, but as long as you're able to figure things out on your own, I'd say that's the #1 skill to have, is just figuring things out. So degree difference is going to be our old angle, then we're going to rotate, and then we're going to, let's see, we want the difference between the two angles, so we want to do absolute value. So mathf.abs. So mathf is a library, basically, or whatever you want to call it, and abs is a function, absolute value. Oh, nice. Angel2196W is following. Thank you. Hope you're enjoying it, everybody. I guess you guys must be if you're following. So, all right. Good to hear. So absolute value, and we're going to take the difference between the old one minus the new one. So old one minus new one, there we go. So, and now we're going to add the degree difference to our total degrees. So then we'll say, okay, we've moved this many degrees on this step right here. And then what we're going to check up here is if the total degrees is greater than or equal to 360, because that's a whole rotation. Then we're going to set it back to 0, we're going to stop spinning, and then we'll wait for the next time. So that means whenever we come back here and I hit the button, it should always stop at the right time. It should always stop after a full rotation. I hope. I hope, because another thing about making games that if you pay attention to this stream or any other game development stream, you'll see is, well, okay, that's broken. But let's turn up the speed a bit. Yeah. What I was going to say is that one thing you'll need to pay attention to is the fact that even if you think something's going to work, there's like a 99% chance that it won't work, and then you'll need to spend additional time figuring out why it doesn't work and then fixing that. Okay, so what's the deal here? Let's output some stuff to figure out what's going on. Let us see what's happening. So let's do debug.log there, debug.log here. So we will say, old angle is going to be this, and we're going to have we're going to say new angle is going to be this. Same thing right there. So that's before rotation, that's after rotation, and then we're going to debug.log the difference. So these numbers should come out right. And then we'll debug.log total degrees rotated. So if there's some sort of discrepancy here that we're able to find, it'll let us know what's wrong, or if anything there is wrong, or if we're looking in the wrong place entirely. Okay, so what's going on? Let's take a look and pause. Oh, it is like in the thousands. Okay. So old is 161, new is 160, difference is 162. Okay, that's not right. That's not even close to right. Why is the difference 162? So, like I said before, by the way, if anybody's able to solve a problem before I am, you can get some bonus points. So, what is the deal here? Why is it? Can anybody figure this out? Basically, we've got our old angle is 161, new angle is 160. Okay, sure. So that means this should be like 1. This shouldn't be 162. $234, 235, that's 233. Oh, I said rotation.z and not Euler angles.z. That's going to make a big difference. Okay. Just a small typing mistake, I think. Because there is a difference between your rotation z and your Euler angle z. So, I don't know how many people... A lot of people are probably new to programming in Unity, so you can see that actually works now. So, the rotation here... this clearly says like 100 something, or like any number from 0 to 360 is going to show up there. But actually, the rotation is stored as something called a quaternion, which has much smaller or much different numbers at the very least. So that's why I was grabbing values from the wrong thing. So anyway, small little detail there. Now for some reason the game is lagging like crazy right now. I don't know why that is. Oh, I know why. Because I'm outputting debug.log statements everywhere. I need to comment those out. So yeah, so that's another thing is like if you output stuff to the debug log, then it will really, really slow your game down. Alright, so we're back to normal now, it looks like. So the whole point is that we can hit the switch and it's going to go a lot faster. And you can see it does, and it should stop, wait for a few seconds, and then continue. And it does. So we're good to go. So that worked perfectly now. Alright, great. I was thinking of doing some more complicated things with this, but I might have to save any more complicated stuff until next time. Oh, now it's a little you see that? It's a little bit tilted. Let me see. Yeah. There's one thing I want to do. I want to fix that so that it's not tilted. So we can remove these debug statements, just we don't need them anymore. And let's see. I was just thinking that we could let's see. We could just straight up set the rotation. Whenever we stop. So whenever we stop spinning, we just want to say transform dot rotation equals, like I was saying, new, well, actually, I don't know if I can make it a quaternion. Let's see what we can do. Can we set the Euler angles like that? Probably. Let's see. So we'll set the Euler angles, and Euler was a famous mathematician. You can look him up if you want to know why it's called that. He came up with these angles, basically. So we just want to copy and paste the original x value, the original y value, and of course our new z value, which is just going to be 0 because we want it to be flat. So anyway, so I think that ought to work. It'll just make it so that it's never tilted when it stops. It'll always just stay flat. What's this error? We can't do that. That was what I was afraid of. We could just do, like, the simplest thing is just do transform.rotation equals, well, I know what we can do. We will do, we'll save a start rotation, quaternion start rotation, because it's really hard to make a quaternion out of nothing if you don't know how they work, and I don't know how they work. So, because those are complicated things. So the start rotation is going to be the rotation at the start. So we'll say in our start function, we'll do start rotation equals transform dot rotation. So simple as that. And now what we're going to do is we're just going to say our new rotation equals start rotation, because the whole point is it goes back to the way that it started after 360 degrees. It should anyway. So all right, and now there are no errors, so we can try this out now. So very slowly, and let me see how it looks when it's slow. So yeah, it seems fine, and it keeps going. It goes faster, and it should not be tilted. Yeah, there we go. See, because you can visibly see that it's sort of like goes too far, but then it corrects itself now. So basically, I guess the idea behind this is to make it so that you can have these platforms going like really fast like that, or you can hit switch, then you hit the switch, and then then we change it so that it goes slower instead of faster. So really, you could have the opposite effect. So yeah, like if we do like it's going at like 500, and the switch, it should actually only change it to, let's say, 50. So we have the reverse situation now. So it's at 500 right now. And it's probably a real pain to jump on it. So we can just hit that. And now it's a little bit easier to line up our shot. Of course, the next the next thing probably is to alternate between the two speeds rather than just setting it to one. Because obviously this is a switch that you can hit, so you can switch it up or you can switch it down. So I guess the logical thing to be able to do is be able to hit it so that when it's up it's fast and when it's down it's slow, and you can alternate between them as much as you want. So it's probably what we should do. So what we could do is we could do public float yeah, here's what we'll do. Public float slow speed equals I don't know, doesn't have to be anything. Public float fast speed, and then we'll say at the beginning, well, which one should it be at the start? Should it be the fast one or the slow one? But what if we don't always want that to be the case? What if I guess you could think of it this way. When you hit the switch, maybe you can just there can be two different functions that you call when you hit the switch. Like when you hit the switch and it's up, do one thing. When you hit the switch when it's down, do a different thing. So maybe that's what we'll do. Yeah, I think that makes sense. So we'll do this function will get the name of the function. You'll see what this is. It'll return a string, so we'll do get function name, and it'll just be this thing right here. So we already coded all that. I'm just putting that out into a into its own function. And then we'll just say this is equal to get function name, function to call. Oops. So that's good so far. But what I want to do is let's see. If the switch is up, then we want to call on impact. If the switch is down, then we want to call a different one. So we'll do, let's see. So if we are rotating down, then that means we used to be up. And if we are rotating up, then that means we used to be down. So we'll just do if rotating down, do that. If rotating up, is there any need for there to be two different functions though? No, I don't think so. We don't need to do that. The idea is just we're going to have two different functions. So switch function, we'll say up function and down function. So simple as that, and then we'll just have a bool here for is up basically, and we'll say function equals that. If is up, then function equals that, else. So if the switch is up, then we want to call up function. If the switch is down, then we want to call the down function. And similarly, there's going to be up parameters and down parameters for each function. So again, all we're doing here is we're just trying to make it so that if you hit the switch and it goes up, then the platforms speed up. And if you hit the switch and it's down, then the platforms slow down. So it's that you're able to control that in that way. I don't think that's ever going to be called. I'm just going to get rid of that. All right, and then the only thing we need to do here is figure out if we're up or not. So if we are up, then if we were up, then it's rotating down. Honestly, it doesn't matter which way it is. We could just reverse it if we want to, if it's not to our liking. So now we're going to have room for two functions from one switch, basically. So let's see how different this looks after Unity reloads after a second. Are you running any stream bots? No. Well, I don't think I am. I'm a little bit new to the whole streaming thing. Well, I'm not new to streaming, but I'm new to streaming on Twitch, so I don't think I know how to code a stream bot. There is the Streamlabs extension that you can see beneath the video screen where, as you guys are watching the video, you can earn points that can be redeemed for a free $1 game if you get 1,000 points. But, I mean, other than that, I don't think there are actually any bots like in the chat or anything. Like, I certainly haven't programmed any. Although that'd be a fun thing to do if I could learn how to do it. So, anyway. So the up function is going to be change speed, the down function is going to be change speed as well. But the speeds that we're going to change it to are going to be different. So let's say we want to change the speed to 500 with this one and 50 with this one. So I guess by default it starts it down. So I guess let's do it the other way then. So by default it starts it down and it's going really fast at first. All right. So let's try it. So it's going fast. Hit switch, it should slow down. And hit switch again, it goes fast again. So yeah, so that works. So So cool. So the next thing, like, we might be able to make it so that there's more than two functions for a single switch, but like, I don't see that really happening because it's like, you know, you hit the switch, it's either up or it's down. There's nothing in between. Unless we want to make a switch that has a middle state, but we don't need to deal with that right now. It's like, for our purposes, this pretty much works the way I want it to. So you can hit the switch to make things go faster or slower, and that's pretty funny. You jump on the switch and it like lifts him up for a second, but then his own weight makes it go down. Alrighty. So we're at the halfway point for tonight's stream, and we made pretty good progress so far, I think. So let's switch to something else. Somewhat similar. I want to make it so that when you flip a switch, well, maybe there should be like a type of a switch that only has one function, maybe. I don't know. Like, you hit it, it goes up, and then it gradually comes back down. Yeah. So my idea was that we could have some timed platforms that when you hit the switch, the platforms appear, and then you have like, I don't know, 5 seconds to jump across all of them all, and after the 5 seconds are up, you can hit the switch again to make them reappear. Sort of like those things in Mario Odyssey, the scarecrow things, but or just the P-switch in general from the Mario games. So I think that would be a pretty cool idea. So how do we want to do this? Well, let's make a new triangle or something. Let's take the triangle that's not moving and just pretend that this is our temporary platform that does not exist. However, it actually is going to exist. We're just going to hide it from people so that they think it's not there until we make it show up. So let's make it a little bit bigger, just because we can. And so this is our invisible platform, basically. It will be timed, and yeah. Now here's the thing. Here's the thing. I wonder, do we want to actually just make it like fade in, like go from that to that? I think we should. So we will not only enable or disable it, but we'll also change the color from that to that. But let's see. What do we need to do to make that happen? Well, we can look at it a few different ways. We've got a switch that we need to hit. It's got to start a timer of some sort, and after the timer is up, it should really probably be its own, well, I don't know. Like, I almost think this should be its own script, but there's so much code in here that I don't want to have to reuse. So maybe we can add like a number here, like public float, let's say timer equals 0. And if the timer is not 0, then that means we're going to have a timer involved, maybe. So we'll do, let's see. Let me just write this out in the form of comments. So step 1 is hit the switch. Step 2 is set the timer. Step 3 is wait for time to run out. Step 4, the switch has returned to its initial position, and then you can do it again. And I guess step 5 is make any affected objects disappear. Same with this. When you hit the switch, make any affected objects appear. So we have a few steps, 6 steps basically. Hit the switch, make any affected objects appear, set the timer, wait for time to run out, switch returns to its initial position, make any affected objects disappear. So when the switch is hit, we'll do something totally different if the timer is greater than 0. Else we will just do stuff as usual. Also, what we want to do we only want to do this when the switch is let's say up, I guess. When the switch is up, we want to do stuff. So where does this number come from? Okay, so that's all it is. So that's all that is, I think. So if we want to use a timer and the switch is up, currently up. So also the other thing that we need to do is check to see if private float next switch time was 0. So we want to say if all of that's true and time.time is greater than next switch time. So then we'll say next switch time equals time.time plus timer. So that'll get that to work. So we'll wait for that many seconds. What else is there? So one is we hit the switch, okay, and we set the timer, but now we need to make any affected objects appear. So what we'll do is we'll say for all of the affected objects, right? So make the affected objects appear, and we'll set the timer. Make affected objects appear. Object dot on impact. Well, I guess what we could do is make sure the function is setting them to appear or disappear. Maybe. Probably. Let's comment this out for right now. We'll just do object dot set active. Oh, what is this? Oh. Okay. Let's see. Oh, okay. I have to do object dot affected object dot set active. There we go. So this will just make them appear. It won't do it in any fancy way or anything. I have a ton of questions, but I'll keep it brief. How much time does it take to produce a level? Depends on the complexity of the level, and what kind of game you're making in general. But if you're talking about this one specifically, it also depends on whether or not we have created all the stuff that we need for the level. Like right now, I'm making some stuff for a level that we will use. Like if I want to have these platforms appear and disappear, obviously this is probably going to take the rest of the hour to well, maybe not that long, maybe half an hour, but it'll take some time to get that working. But if we assume that I have everything already programmed in, it can maybe take like 1 to 2 hours. I've done a few streams in the past where I've just done nothing but design a level. It can easily take 1 to 2 hours for a fairly lengthy level of, like, let's say 3 to 5 minutes of gameplay. If you want a level that's 3 to 5 minutes long, it can easily take, I'd probably say, like, in just as an estimate for this game at least, 1 minute of gameplay is like 1 hour of work, probably. And that's not counting stuff like testing the level to make sure that it works, or to make sure that it's fun, or to make sure that, you know, all the graphics and stuff is polished and all that. It's just like laying the foundation for the level. You could say is 1 hour per minute of gameplay that you want it to have. That's my guess. It's not an exact science, and I'm not saying I know exactly how long it would take, but for this game in particular, that's how it is. And each game is going to have its own different answers too. So, okay, let's look at our checklist. So we set the timer. And now we wait for time to run out. So in the update function, we can just check right here. If timer is greater than 0 and time.time is greater than next switch time, so time has run out, then, and by the way, I don't mind any questions either, so if you come up with more, feel free to keep talking about them. It's fun to talk with people, so I don't mind. And I also don't mind if anybody just wants to stay silent. People can do whatever they want. Just enjoy the stream. So, like I said, we wait for time to run out, and now time does run out. So what we do here is we say, well, I can just copy and paste this, basically. And we'll say, we will make those objects disappear. So simple as that. Because if we want to make them gradually disappear, we'll have to do something more complicated, but this gets the point across. Switch is returned to its initial position. Okay. So the only thing we need to do is make the switch revert to its rotation. So, yeah, I guess that's what we'll have to do again here. We'll have to do a start rotation for this. So it's exactly what we did with this one. We'll go to start rotation. Just copy and paste all of that. It's the same thing. We'll just say rotation. Oops. Transform dot rotation equals start rotation. So that's it. And this isn't going to be very pretty or anything, but it should work. The only thing is, I think the switch has to be up to start with. So $45, like that. Actually, let me duplicate the switch because I like the other one. So this is going to be our change speed switch, and that's fine. This is going to be our time platform switch. So 45, positive 45, so it tilts up like that, and we want to make the affected object to be this thing, triangle 5, which is not really a triangle. That's more like a trapezoid. But anyway, it doesn't matter. We'll call this time platform. And let's see, is there anything else that I forgot to do yet? Well, it should start being disappeared like that. So we'll hit the time platform switch, and we will say the timer should be like, I don't know, 3 seconds. So we'll hit the switch, and after 3 seconds pass, we hit the switch, the platform shows up, 3 seconds pass, it disappears, and we hit it again, and it works the same. I think that ought to work, and I don't think we have to mess with the parameters or the functions either. It just never is taken into consideration. But it might be soon. So hit the switch. Uh-oh. Change speed has no receiver. Hold on a minute. Oh, I see what we're doing. Yeah, that can't be that way. So if timer is greater than 0, then we do want to go into this. But then only if, let's see. Let's do it that way. I had the condition backwards on this, I think. The only nice thing about Unity's slow loading times is that it gives me some time to drink some water in between talking. All right, does that work? Let's see. Like, the Z value is 45. Like, what happens if we do that? No, nothing. I'm going to debug.log and see what's going wrong here. Alright, what is this? False. Okay. What? Okay. So 78, line 78 is false. That's the problem. Line 78 is Euler angles.z. Why would that be false? Because you can see the z value right there is 45, so I don't quite get why that would be the case, that it would return false. Okay, come on. There we go. See, it's like, what the heck? This thing is lagging like crazy. Alright, there we go. So false, but 45. That doesn't make any sense. It's returning false. It's clearly 45. Like, that doesn't make any sense whatsoever. And so line 80 is also true, which is fine. So line 80 is true, which is good. So we don't need to worry about that. But this is false for whatever reason, even though it is 45. Alright, I guess here's what we can do. We can say, if up, what is it? If we're not rotating down, I'll just phrase it like this. If we're not rotating down, I'm not sure what was the deal with that, then we'll just say we are rotating down after we hit the switch. And then we go back up here, I'll just say we are not rotating down anymore when we're done with it. Like, that's as simple as it gets. I don't see why that wouldn't work. There we go. There we go. See, it's not actually rotating down, but it did make the platform appear and disappear, and it'll do it for every platform that we add to the list. So now I don't think 3 seconds is nearly enough time to actually jump on it, but maybe that, yeah. If you get on it like that, then sure. But yeah, so now we've got our appearing and disappearing platforms, sort of. It doesn't look very nice, and the switch doesn't actually rotate. So We'll need to add that in. That might take another 20 minutes or so. And maybe we'll have some extra time for some more stuff after this, because we usually end at the same time. But I don't want to risk it. I don't want to risk going over time tonight. Let's see. So we want that to rotate when we hit it, basically, into a down position, basically, as it normally does. Well, maybe I have these backwards then. It must be backward. That's really weird. What happens if I just switch this out, down and up? Will it start to move then? Yeah, that worked. So I guess I had it backwards. That's weird. All right, and so you can see it automatically sets itself there. It resets itself, and then it just stays that way forever, I guess. So it goes down, and then back up, and it stays up. It's weird. I guess it's because this. So we'll just add that condition to it, and if it's rotating up, we'll just add that condition to it. Because it was just constantly resetting its rotation the whole time. Uh-oh. That might not ever get called. Let's see. Yeah, I see what's going on. I'll say else if rotating up. Well, no, that doesn't make sense. I guess I can just do this. We can just, no, wait, I know what to do. No. Oh, darn it, this is tough. Here's what we'll do. I'll just say private bool timer active. All right, and we'll just say if timer's active, we'll do that. Timer active is false there, and timer active is true there. It's not the best way to do this, but it works, because the issue was that I had a separate part of the update function making it rotate, making the lever rotate, and so it stopped rotating before the rest of it had finished, before the timer had finished up. Okay, well, still not working. Oh, I know what's going on. Just on impact, I think. Well, no, because this never happens. It's weird. I don't know. Again, if we get stuck, and if people can think of a way to get unstuck, then you can get some points. Because this is the part where I'm like, I don't know what I'm doing wrong here. Oh, it's because the number is different. This number right here. Okay, I know what this is. Okay, let's change the word number to current angle. And we can just set this current angle equals oops. Say current angle equals that's why it was backwards. I got it. Maybe. Maybe not. I don't know. We'll say current angle equals 45. And okay. So current angle is the current Z angle, basically. And I was messing with that to try and make the lever go up and down from a few weeks ago when we streamed that episode. So because of that, I forgot to set it to 45 here. And because of that, it thought that it shouldn't have been reset. So if this doesn't work, then at least I know what's wrong. And so many times when you're coding a game, you can actually be your own worst enemy if you code something that you forget about like weeks or days later. So that's another important thing to remember. So if that's down, then it'll go back up and goes back down again. Okay, so we solved that. That was my fault. So that's why it's important to name things with good names and stuff like that. Don't forget what you're doing. If you do forget, write a comment somewhere to let you know what you're doing. Or better than a comment is to just have a very descriptive names for your variables and your functions. That way you don't need comments and the code itself is pretty readable on its own. So yeah. Probably what we should do in the future is make it so that it's pretty obvious which switches can be hit. Like if I try to hit that now, it won't do anything. Like I can only hit it and it only turns one way. So we should make it sort of obvious which switches are like one-way only functions. Or one-way only switches. Maybe like the color of the knob. Like a red one can be hit as many times as you want, but a green one can only be hit once before you have to wait for it to come back or something like that. Probably something like that. But that's sort of when we get into the graphics department of it all. And speaking of graphics, what we want to do is make this platform fade in and fade out. And maybe that's going to be the last thing that we do tonight, because that might take a little bit. We just want to set the renderer of this thing, the alpha channel of it, to go from 0 to 1 over time, basically. So I think I might actually have some code for that. It's from a different project, so let me grab that really quickly. Because it's always helpful to just be able to copy and paste code from stuff that you've already done and projects that problems that you've already solved, basically. All right, so how do we want to do this, I guess? I guess it'll be part of the switches function, because that's enough, I guess. So if the timer is active, then we want to do something. And if the time is greater than the next switch time, then we want to end it. But otherwise, we might want to do something else. So in our case, we want to, yeah, so in our case, we want to get the objects to spawn, basically. So here's what I can do. If I can hopefully just copy and paste this in here. Okay, I can't. That's okay. I'll just type it in again. So we will say actually, this is kind of bad. Yeah, I'm gonna go with a different way of doing this. We're gonna make a script just for these things, and we'll attach it to whatever we need to fade in or fade out. And maybe we'll combine it with a different script or something. But we'll say, oops. Unity froze again. Okay, there we go. Say new script, fading. I guess we can say fade sprite. That's the most descriptive name I can think of for this. So we'll give that a fade sprite script. So what we'll do in the let's see, update function, we'll have some variables. One is bool fade in, one is bool fade out, and we will have private sprite renderer SPR. So if fade in, then we do something, and else if fade out, we do something else. As simple as that. So when we hit the switch, what we're going to do is not only are we going to actually, we don't even want to set them inactive anymore. Actually, yeah, we do. Well, we won't do it here. We'll do it somewhere else. But we'll do object.fade out. Whoops. Object.affected object.component fade sprite. So we're getting the script that we just made, and we're going to say fade out equals true. And down here, we're going to do something similar. We will set it active there, and we'll do fade in equals true. Okay. Then over here in this function, hey, how's it going? Pretty good. We did a lot today. We fixed some of the rotation with the other platforms that we messed some things up with. Well, we didn't really mean to mess things up with, but accidentally, based on what we were doing last time, we had some unintended side effects that we had to fix. So we fixed those, and then we made a switch that changes the speed of the rotating platforms back and forth. So now we're doing a switch that spawns, well, it doesn't spawn them, it just you know, makes them visible or invisible platforms, like in, for example, Super Mario Odyssey, with the Scarecrow minigame kind of thing. You throw your head on the Scarecrow and some platforms appear, that kind of thing. And this is the code for fading in and fading out the platforms, the sprites at least. So I'll do sprite.color equals color.lerp sprite.color. So we want to go from the current color to I guess color.white. Well, I don't know. We don't know if that's actually what we want. So we'll say public color color. Man, that's not descriptive at all. Well, we'll say default color. So we want to go from whatever it currently is to what it should be. And time.delta time. And then we'll say if sprite.color.alpha is greater than 0.99. Well, yeah, I'll go with 0.99 or something like that. Greater than or equal to it. Then we will just say sprite.color equals default color and fade in equals false. Gotta bail now, Murray Coding. Thanks. Yeah, thanks for watching. See you around next time. Let's see. You want the alpha channel to go from 0 to 100? Yeah. Yeah, that's exactly what we're doing. I've done this particular problem a number of times, thankfully, so you'd think I'd have a better way of doing it by now. Or that I'd have like a chunk of code I could just put in here, and I think I sort of do. But yeah, the range is from 0 to 1, basically. And then it's sort of the opposite effect for this one. If we're fading out, then we want to... Wait a minute. Yeah. This one's a bit trickier though. So we want to do new color, which is going to be default color dot R, default color dot G, and default color dot B, and then it'll be sprite dot alpha, I guess. Well, I don't know. Wait, no, I'm doing this wrong. This one has to go to 0 because this is the final color that we want to end at. We still want it to have these RGB values, but we want the alpha to be 0. This is sometimes the problem that with coding close to like my time. It's going to be like 10 p.m. so it's like sometimes it can be kind of rough, but usually I wake up late enough in the day where it's not a problem. So, and then this has to be the opposite. So when it gets to be less than or equal to, let's say 0.01, because I'm not quite sure if it gets all the way down to 0 very easily. Then we want the color to be like totally clear, basically. Well, we'll just say new color again. And we'll say fade out is false. And the other thing that we need to do is we need to this.gameObject.setActive false. I might put this somewhere else, but the idea is that when we fade out, we want that to also deactivate the object. So now we also might want to have a speed factor. So let's just do public float speed like usual, and we'll do we'll make it like, I guess, 1. It'll be kind of slow at 1. Maybe we'll do like 100. We'll do speed times time.delta time. So that'll affect the rate at which it fades in and fades out. I think that's pretty much what it is. We might need to fix a few things because I always hesitate to say that it will work on the first try, but that's basically the idea. So yeah, this time platform has a fade sprite stripped on it. Default color is going to be white. It's important to set that. And let's hit play, I guess. I hope I set everything up the right way. Let's see. Something's not set right. What's this? Fade sprite 18. Oh, duh. What am I doing? We forgot to set this. Start function, we want to SPR equals this type. Object to component, sprite renderer. See, very simple step that I totally forgot. Also, the other thing that I forgot is that this thing needs to actually, the actual color that this thing needs to be should actually be a clear color to start with, and I forgot to do that. There it is. So this is actually the color that it needs to be, is that thing. It shouldn't be totally white, and it should also be, alpha should be 0 to begin with. So we'll drag that down. Isn't isn't this game object redundant? Probably so. I don't. Somebody else asked that, I think, a while back, if there was any difference between that, and I don't think there is. I don't know. To be honest, I don't know. All right, let's see what this is. There's no sprite renderer. Oh, that could be a problem. Let's see. So what is this? I forgot about this because this is something I got off the asset store. So maybe this is not a sprite renderer. I mean, apparently it's not. So what do we call this? For 2D path terrain. So I guess we'll just have to use for 2D path terrain. Let's see. Dot what should it be? What is it? Vertex color, that's it. So we'll change color to vertex color. So this will be a specific script that does this for these terrains. Forgot about that. Well, what happened here? Is it enabled? It's enabled. Let's see. What could be going wrong here, I wonder? Let's give the switch like 10 seconds instead of 3. Yeah. Oops. I'll do 9. So what's going on with this thing? I mean, it looks like, to me, it looks like the alpha is full. So what's the deal? You know what? I think I know what it is, because I changed. these things are special. These are different from like your average sprite renderer thing. I changed the color of it in the other game, the first Snowball game, that's on the Android platform right now, on the Google Play Store. In that game, there was one part of toward the end where I changed the color of the terrain, and it was complicated to figure out why it wasn't working. But it's because of the way those things are made. Whoever made the asset that I'm using. I need to check how I did that exactly. Okay, you have to do force material terrain material true. Okay, so back in here there's something that we need to do that's very specific to this asset store package. So whenever we change the color, we have to do this sprite dot force material sprite dot terrain material true, and that just applies the changes to the color to the actual object. Alright. That could have taken us a very long time if I hadn't dealt with that in the past. But that's just a way that code was made. So okay, well, it shows up. It might be actually fading in and out way too fast. Yeah, so that's 10 seconds. Okay. Yeah, let's turn down that speed a little bit to like 10 maybe. Where'd it go? Time platform. Let's just turn that down to like 10. There might be something else wrong with this now. I mean, clearly the color is changing, but the rate is wrong, it seems like. Just add a debug.log to see what's going on here. It's actually quite possible that it's just going too fast, maybe. Like, still. Yeah, it just, like, jumps up there. Let's make it even smaller, I guess. Speed's gonna be, like, 0.5. I mean, I guess that makes sense, because the alpha channel goes from 0 to 1, so maybe it just needs a small number. Yeah, okay. There you go. Okay, sure. So, it just had to be really small. Let's make it like, let's make it like 2, I guess. I'm having such a hard time making my character controller properly use the cameras. Is it like a 2D camera controller? Or a 2D character controller? I assume. Nice. So that works. I don't know a whole lot about the character controllers just yet. Like I know a little. I've used them sparingly myself. This guy doesn't actually use one. He's just a round ball. So I actually don't know if I can provide that much support on it. 3D, you were inspiring me to just make it 2D. Well, it's certainly a lot easier to do it in 2D. Like, obviously, because you have one less dimension to think about. Yeah, and I think I said before, I don't have a whole lot of experience with 3D. I've tried to do stuff in Blender, but that hasn't worked out so well. And, like, that's really the biggest barrier to 3D, I think, is that if you don't have the polygons or the character models, then it's like, or if you don't have the ability to animate them and, you know, doing all sorts of things, it's like, it makes it so much harder. But I can go into Paint and, you know, whip up a round circle with this guy. That's exactly what I did, actually. Okay, let me make this like I don't know, 4 instead of 2, and I think we'll just call it done after this. That's pretty good. I'd say that's pretty good. And let's just test out the staying on it. Yeah, okay. Maybe we'll make it a little bit faster than that. Let's try 8. I'll go with 8. Alright. Okay, so I think that just about does it for tonight. So, once again, thank you all for watching. We had a lot of people tonight as well. Oh, and before I go, I want to, if this thing will refresh itself, I'd like to mention the leaderboards to see who has the most points right now, because I think that's fun. Let's see. Let me just look at it from my dashboard. It's easier. But yeah, we accomplished a lot today, and I think we will definitely keep going with the factory. I have some other ideas for this stuff that some of my teammates know about. They've inquired to me about my plans, and so I've told them. But yeah, let's see what we've got here. Alright, so first place, it looks like got Timothy V first place with 148 points, Sound T777 with 135 points, and Gungalow and Bo 2015 are tied at 115 each. I think. Yeah. Okay, good. So at least that's what I'm able to see. So yeah. I don't know if that leaderboard is not working for other people. It seems to be having trouble on my end, but anyway, I can read it from my dashboard. So anyway, I'll double check all of that stuff, and I'll make sure to upload a game page for Snowball Safe Summer on the official Goldbar Games website. That way people can start redirecting people to the page or whatever they feel like doing. If they feel like looking at screenshots from the game or whatever, there's not going to be a whole lot of stuff there yet, but there will be a nice description of what it's about, the planned release date for it, and so on and so forth. I just haven't had a whole lot of time to set it up properly. But anyway, I'll get that done soon. So thanks for watching, and let's see. Hold on. One more comment I should address. Let's see. Wanted to delve into the art of game design and making complex story games, but then I found this stream, so I've been sticking around. Well, it's a very good comment to end the night on. So thank you for sticking to the stream, and hopefully you'll stick around a lot more. So see you next time. Thanks.